Hello, and welcome to today's lesson on the national grid. Today, we will explore what the national grid is. Then we will understand how electricity is transmitted from power plants and explore the challenge of reducing energy loss in transition. Finally, we will explore transformers and their role in minimizing energy loss. The national grid is the network of cables and transformers that distributes electricity from power stations to homes, schools, businesses, and other facilities across the country. The national grid plays a crucial role in ensuring that electricity generated from various sources reaches consumers safely and reliably. But one key challenge in transmitting electricity over long distances is energy loss. In transmission wires, some energy is lost as heat due to the resistance of the wires. This power lost as heat can be calculated using the formula P equals I squared R, where P is the power loss, I is the current, and R is the resistance. We need to reduce this power loss. Since power loss in the transmission lines is proportional to the square of the current, if we lower the current, the energy loss decreases significantly. Therefore, in transmission lines, electricity is transmitted at high voltage and low current to minimize power loss. To achieve this low current, high voltage transmission, transformers are used. At the power station, generators produce electricity at a certain voltage. For example, the generator might send a current of 1,000 amps at a potential difference of 25,000 volts. However, if we were to transmit the electricity at this voltage and current over long distances, the energy loss would be substantial. To address this, a device called a step-up transformer is used. This transformer increases the voltage while decreasing the current. For instance, it can increase the voltage to 400,000 volts and reduce the current to 62.5 amps. By doing so, the power loss due to resistance in the wires is minimized, making the transmission process much more efficient. However, while high voltage is great for reducing energy losses during transmission, it's not safe for end users in homes. When electricity reaches closer to your home, another device called a step-down transformer is used. This decreases the voltage from the transmission lines to a safer level, typically around 230 volts in homes, and increases the current to usable levels for household devices. In addition to managing voltage levels, the national grid also has the important job of balancing electricity supply and demand. To achieve this, the national grid continuously monitors electricity usage and adjusts the output from power stations accordingly. For example, if demand increases suddenly, like when millions of people turn on their kettles during a TV ad break, the national grid can quickly ramp up electricity production from power stations or draw on stored energy reserves. In summary, the national grid is the backbone of the UK's electricity system, ensuring that electricity is delivered efficiently, safely, and reliably to where it's needed. In today's lesson, we explored the crucial role of the national grid in delivering electricity across the country. We discussed that the national grid is a network of cables and transformers that carry electricity from power stations to homes and businesses. We also highlighted the challenge of energy loss during transmission and the importance of minimizing this loss by transmitting electricity at high voltages and low currents. By using step-up transformers, the voltage is increased for efficient long-distance transmission, and then step-down transformers reduce the voltage to safe levels for everyday use in homes. Finally, we touched on the national grid's vital role in balancing electricity supply and demand. In summary, the national grid is essential to maintaining a stable and efficient electricity supply, ensuring that power is delivered where it's needed most while minimizing energy losses and maintaining safety.